some multiplying, some dividing with rational expressions. We're going to simplify them. And then that last part there says identify where it's undefined. So remember we did that in the last section, right? Do you guys know what a rational expression is? It is so rational really just means fraction. Okay, so if it's a rational expression, it means that there's a fraction in it. And we know that with fractions, what do we have to watch out for? When do you have something that's undefined? Yes, you cannot have 0 in the denominator. Okay, so rational expressions, they're numbers that can be expressed as a fraction. Okay, and that's where the numerator and the denominator are both integers. And the denominator cannot be equal to 0. So for the first one, it asks us to simplify and then identify any x values for where it's undefined. So identify any x values where it is undefined. So that just means you have to find where the denominator cannot be 0. Okay, and then we'll talk about that. And then keep those rules of factoring in your head. We're going to talk about that in a little bit as well. Okay, so for part A, we have 10x to the 8th over 6x to the 4th. So when you're simplifying this, you can think of this in terms of the numbers and of the variables. So I like to think of it as the fraction 10 over 6 times x over 8, x to the 4th, because you're going to simplify the numbers and then you're going to simplify the x values. So what's the number that goes into both 10 and 6? 2. So when you divide by 2, you'll get 5 over 3. And then when you divide and you have the same base, do you guys remember what you do to the exponents? Subtract. Yes, subtract. And then, so that would be x to the 4th. So your final answer would be 5x to the 4th over 3. Because what happens is when you do 8 minus 4, you get x to the 4th. That's going to go on top because the 8 is on top and that's the larger number. You can also, you may also see that answer written like this with the x to the 4th on the side. Either one of those would be acceptable. So now we have to find where it is undefined. Okay, and you have to make sure that you're using this denominator here. So you have 3. If you set 3 equal to 0, there's nothing to solve for. So in this one, that you have no restrictions. Okay, so you don't have to worry about saying what x can't equal for that. Alright, now for the next one, we have 3x plus 4 over 3x squared plus x minus 4. Alright, so I told you to think about our rules for factoring. You guys remember what I said it was like? Rules of factoring are like the rules of what? Yeah, rules of factoring are like the rules of dating, because the first thing you want to do is what? Check to see if you have something in common. Okay, so the greatest common factor, that's what we take out. What do you have in common? Okay, then after that, you want to see what is... Yes, I like that. Yeah, special, right? So what is special about them? Okay, in terms of factoring, we'll have special patterns, right? Like the difference of 2 squares, the sum of 2 cubes. All right, so once you've done that, then you want to what? Just give them a chance, right? Just guess and check it out. Okay, so we're going to guess and check. And with this, we're going to guess and check with FOIL. Okay, so what they have in common, is there anything special? Guess and check, make sure that you FOIL. Okay? So the numerator, 3x plus 4, nothing you can take out, not a trinomial, so you can't factor it. So you're just going to leave it as 3x plus 4. Now, and this is a factor, so sometimes I'll put it in parentheses. Anytime you have a fraction, there really are parentheses around the top and the bottom, because you have to simplify the top and the bottom separately. That's why there's only certain things you can cancel out, so we'll talk about that today as well. Now, when you're factoring a trinomial, remember you have to look at the first number. So if it's 3x squared, what do I start my parentheses with? Yep, 3x and x, because 3x times x is 3x squared. Okay, and then it has to multiply to that last number, which is a 4. So my only options are 1 and 4 or 2 and 2. Okay, so let's do some guessing checking. So it's either 1 and 4 or 2 and 2. What do you guys want to try? Okay, and then let's look at the sign. So if this is a negative, right, what do I know about my signs? Yep, one of them is negative. Normally I just throw it in there and then see what happens, and then I'll switch if I need to. Okay, so it has to add to 1. So if I put the 4 here and the 1 here, let's see what happens. So I'm checking with FOIL, so I'm going to check the inside, which is 4x. What's 3 times negative 1? Yep, negative 3x. And that adds to, yay, x. That's what I want in the middle. Right? So the main thing that we're checking is the middle, because I've used all the rules for the rest of them. So this is going to be plus 4 and minus 1. Just make sure you do that check, and it's fine for you to do it in your mind. I just want you to remember that you do multiply by what's on the outside there. Okay, so do your check. All right, now we get to cancel. So when you cancel, just make sure that you do 1 slash so that we can read what's underneath. So you have multiplication here, okay, and this is division. So if you have the same factor on the top and the bottom, those can divide out. Because what's anything divided by itself? 1. So this and this are going to divide out, and 1 is going to be left in its place. So if you can divide them out, you will. So then your final answer for this would be 1 over what's left on the bottom. Yep, so it's going to be 1 over x minus 1, and then you do have to say the restrictions for this. Now this one's a little different than part A. So there's actually 2 restrictions. We did talk about this a little bit earlier. Whenever you have your denominator, before you cross those out, you have to make sure you take into account both of them, because you wouldn't be able to cancel those out unless this was not 0. So for the denominator, if the denominator cannot be 0, that means 3x plus 4 can't be 0, and x minus 1 can't be 0. So you have to find both of those values. Is it okay if I solve it in one step? Like you would subtract the 4, and then you divide by 3, right? So this would be x can't be negative 4/3, and then this would tell you that x can't be 1. So your final answer would be where x can't be negative 4/3, and then comma 1. And this would be your whole answer for that. So make sure that when you are doing the restrictions, you take both of those in. All right, now for C, we have 6x squared plus 7x plus 2 on the top, 6x squared minus 5x minus 6 on the bottom. What I want you to do is start some guessing and checking here. So let's think about our options. So if it's 6x squared, right, what are my options for this? I can do 3x and 2x. I can also do, yep. Now guys, this one really isn't bad because look at the last number. The last number is 2. What's the only thing that's going to multiply to 2? 1 and 2. Okay, so I just have to put them in the right place. If this is positive and this is positive, what are my signs? Yeah, plus and plus. Okay, so I want you guys to try to fit 1 and 2 in here so that the middle adds to 7. Okay, and I'll give you a minute to do that, and then go ahead and try the bottom one as well. Once you figure out the top, when you go to the bottom, remember we're trying to cancel things out, so let that help you a little bit. Yeah, 1, 2, 7, 8. Yeah, so this is going to go here. All right, you guys are doing a nice job with the top. So what did you guys get for the top? 3x what? Good, and 2x? Nice. All right, now when I say, oh, let that help you for the bottom, if things are going to cancel out, I'd probably bet that we're going to start with 3x and 2x, right? So let's try that first, the 3x and the 2x. This one has more choices because if you have -6, right, you could have 1 and 6, you could have what else? 2 and 3, so you have more options. Remember that they have to add to -5. So do you guys want to do some guessing and checking together? Okay, so this is what I would do. See how this is 3x plus 2? I would either try this as 3x plus 2 first, or I would try this one as 2x plus 1 first, just to see if there's going to be something that canceled out. So if I put this as 3x plus 2, what would this have to be? -3, right, good. Because I have to multiply, 2 times -3 has to multiply the -6. So now let's check it. So 2 times 2x is 4x, 3 times -3 is -9. What's 4 minus 9? -5. All right, we did it. Yay. Now we get to cancel. All right, we're ready to slash. And then, again, make sure you do it neatly so I can read the numbers that are underneath, okay? And then your final answer would be 2x plus 1 over 2x minus 3. Now, I'm going to tell you, you cannot cancel out these 2x's. Okay, a couple people tried to do that on the last quiz when we had the division. Okay, this will not simplify to that, and that's because remember, when you have a fraction, this is a factor. You have to do this before you divide. You have to do this before you divide. Okay, so if there's addition and subtraction, not multiplication, you can't cancel it out. Okay, so those do not simplify. It only simplify if it was being multiplied, and it's not. Kind of like with your radicals, right? You can simplify radicals with multiplication, but you can't if it's addition. All right, let's find out what x cannot equal. Again, remember you have to take both of these into account. So, I'm going to do that. The denominator can't be 0. So you have 3x plus 2, that can't make a 0, and then the 2x minus 3 can't make a 0. And you're just solving these for x. So you subtract 2, divide by 3. Just be careful, make sure that you remember to do the opposite there. That's sometimes where people make a small mistake. So x can't be negative 2/3 or 3/2. And then D is going to be a little bit different. So we have 4x minus x squared over x squared minus 2x minus 8. Okay, so notice in the numerator it's not in standard form. Okay, if you ever have these that are not in standard form, I would write them in standard form, which means the x squared term is going to go first. Okay, so this would be negative x squared plus 4x. And that way you can factor out that negative. Okay, so you're going to factor out the GCF and the negative in this step. Okay, what value goes into both of those? What can I take out of both? What do they have in common? X. So I'm going to take out a negative x. This is a trinomial, so I am going to factor that. Remember, when you take this out, it's like you're dividing. It's not like you're dividing. You are dividing. A lot of times I think of it as multiplication, though, too. So negative x times what would make negative x squared? X. What would I multiply by negative x to get to a positive 4x? Negative 4. And then again, I do a mental check. Negative times positive, okay. Negative times negative, okay. And then I'm ready to factor that trinomial. So what's nice about this trinomial is you start with x squared. So when you're checking back with FOIL, it's a lot simpler. You don't have to worry about the multiplication because it's a 1x. All right, so I have negative 8. So let's figure out what my options are. If it's 8, it's either 1 and 8 or 2 and 4. What's going to add to negative 2? Yep, which one has to be negative? Negative 4, positive 2. So negative 4 plus 2 is negative 2. Yep. Okay, so then let's cancel out. Because see how this is multiplied and this is multiplied? That's why we can cancel out. So x minus 4 divided by itself is 1. 1 times anything is just itself. So this is going to be negative x on top over x plus 2. Again, this is plus, so do not cancel those out. You cannot cancel here. You can only cancel when things are being multiplied. And then we also have to find where x cannot be. Okay, so remember, take both of these. X minus 4 can't be 0. X plus 2 can't be 0. So what are the restrictions? Yep, x can't be 4 or negative 2. Okay, and really you're going to start to get really good at this part, so once you see that this is the denominator, it's fine if you just put those on there, okay? Alright, so I want you guys to try this one on your own. Negative x squared plus 3x over 2x squared minus 7x plus 3. You guys done? Okay, what do we do on the top? Yeah, you're going to take out the negative what? Yeah, so if you factor out the negative x, what are you left with in the parentheses? Good. And then in the denominator, you would start with 2x and x, right, to get 2x squared. Well, this is another nice one, because what's the only thing that multiplies to 3? 1 and 3. Okay, so you got to put the 3 here so that you can multiply it by the 2. And then this is negative, so both of these have to be negative. Okay, so this would be negative 1 minus 6, which would add to negative 7. Okay? All right, so now we can cancel x minus 3 and x minus 3. So you have negative x on the top over 2x minus 1. And this is where x can't be, what did you guys find? Okay, so x can't be 3 or x can't be what? 1/2. Okay, so x can't be 1/2 or 3. 1/2 times 3. All right, great. Questions for me on the simplifying part? Then the next few parts, there's going to be a part of the direction that you'll like, because we won't have to do this, where you have to identify the restrictions. So example 2 says to multiply and assume that all expressions are defined. When you assume that all expressions are defined, you don't have to say what x can't be, okay? Because that's already included now. So if all expressions are defined, you don't have to say what x can't be here, okay? All right, so you are going to leave your answers in factored form, which is a good thing. It'll be less work. Okay, so you're gonna leave your answers in factored form, and then you are still gonna factor where possible. Okay. So for part A, we have x minus 3 over 4x plus 20 times x plus 5 over x squared minus 9. Okay. So when you're doing this, we're gonna write out our factors. So 4x plus 20, you have a GCF. You can take 4 out of both. If you take 4 out of both, then you'd be left with x plus what? 5. 4 times x is 4x, 4 times 5 is 20. And then times, we have, and I do want you to think about, too, how you multiply fractions, okay? X squared minus 9, that's special. What's that pattern? What's that special pattern? Yes, the difference of 2 squares. So can you guys fill in what that should be? Remember? Yeah, x plus 3x minus 3. How do we multiply fractions? Yeah, you go straight across. Okay, so top times top, bottom times bottom. Before we do that, though, you can do your cancellations. The only way you can cancel if one's on the bottom and one's on the top. Because what's x plus 5 divided by itself? 1. Anything divided by itself is 1. So I'm just going to write 1's there once I cancel it. X minus 3 divided by itself, that's going to be a 1. Okay, so on the top now, I have 1 times 1, which is 1. On the bottom, you have 4 times 1, which is 4. 4 times x plus 3, leave it like this. You do not have to distribute. This is factored form. Okay, so when it says leave in factored form, that means do not distribute or FOIL. So don't distribute, don't FOIL. You've got to keep that GCF out there, okay? All right, you want to try the next one by yourself? So 10x minus 40 over x squared minus 6x plus 8 times x plus 3 over 5x plus 15. So remember your rules. First thing you want to do is take out the GCF if there is one, okay? All right, let's look at the numerator here. So what can we do with 10x minus 40? Yeah, so let's take out the 10 over here. Okay, so I have 10, x minus 4. Okay, and then this is just going to say the x plus 3. This one was probably quicker for you, right? 5 times x plus 3. Take out the 5. And then you had a trinomial. So the trinomial means you have two brackets here, x and x. So what's going to multiply to 8 but add to 6? Negative 6. Yeah, so, and then they'll both be negative. So negative 2, negative 4. Great. All right, so now we're going to cancel. A lot of times when I cancel, I do start here. So x minus 4. Yep, something on the bottom. X plus 3, something on the bottom. Now, whenever you have two numbers, the 10 and the 5, those can reduce as well. What is 10 divided by 5? 2. So you can say, oh, 5 goes into itself one time. How many times does 5 go into 10? Twice. So in the numerator, you'll have a 2 left. In the denominator, you'll just have x minus 2. And you could simplify it this step, or you could simplify it another step. So if you had the 10 over 5 times x minus 2, you just have one more step to do, okay? And for this, you don't have to say what the restrictions are, because everything's defined. All right. Yay, for this next set, we again can assume that all expressions are defined, okay? And then the indicated operation, we're going to do more multiplying, but we're also going to do some dividing. So let's remember our rules of multiplying. If you have the same base and you multiply those variables together, what do you do with the exponents? Add them. Good. So this is the general rule that you would have learned in algebra. And then for division, you have a to the m divided by a to the n. And with that one, you do what with the exponents? Good. And then the last one is, remember, if you encounter a negative exponent, you put it over 1 and then it becomes positive. I'm going to show you another way to think of negative exponents as well, depending on your situation. Okay, so we have 3x to the 5th, y cubed, over 2x cubed, y to the 7th, and then that's going to be multiplied by 10x cubed, y to the 4th, over 9x squared, y to the 5th. Alright, with these type of problems, there's lots of different strategies you could do. You could start simplifying right now. I find it easier sometimes if we just multiply straight across and then do our simplifying. So if we do that, we'll do number times number. So 3 times 10 is 30. And then x to the 5th times x cubed would be x to what power? Yeah. And then y cubed times y to the 4th would be y to the 7th. And we'll do the same thing with the bottom. Okay, so I'll give you a few seconds to do the bottom by yourself. Okay? Okay, Jack, can you tell me what your denominator is? Good. 18, 2 times 9, x to the 5th, y to the 12th. And now we can reduce. So when you reduce the numbers, you do want to pick the biggest value that goes into them. What's the biggest number that goes into both? Yep. So 6 goes into 35 times, 6 goes into 18 3 times. So 5 on top, 3 on bottom. Subtract here. 8 minus 5 is what? 3. So because that is positive, it's going to go on top. Okay? 7 minus 12 is negative 5. So to make it positive, you have to move it to the bottom. So it'll be y to the 5th, but in the denominator. Now, another way you can think about that is the variable always is going to go where the bigger number is. So with the x's, what was bigger, 8 or 5? 8, so that goes on the top. 7 or 12, 12 is bigger, so that's why the y to the 5th ended up in the denominator. And I like thinking of it that way instead of thinking about the negative, okay? All right, you guys want to try this one? X over 15 times x to the 7th over 2x times 20 over x to the 4th. And again, I would try that strategy where you just multiply everything straight across, okay? finish that one quickly? You want to start thinking about C? You can. Alright, let's check part B. So if you multiplied straight across, then you would have got 20x to the 8th. On the bottom, 15 times 2 would give you 30, and this would be x to the 5th. Okay, now 20 and 30, what's the biggest number that goes into each of those? 10, yep, so it would just be 2/3. 8 minus 5 is 3. So you could write this as 2x cubed over 3 as your final answer. Or you could write it as 2/3 with the x cubed on the side. Okay, either one of those are fine. You just cannot put the x in the denominator. Okay, but this is acceptable as well. All right, did you notice that C was division? What's the rule for dividing fractions? Yeah, you gotta multiply by the reciprocal. Okay, so this is going to be 5x to the 4th, so keep the first one. And then we're going to multiply by the reciprocal. And then if you want to, you can start canceling things out here. So we are multiplying by the reciprocal. The reason why this would be a good time to cancel things out is see how you have 8 on top and 8 on the bottom? So you know that's just going to make 1, right? 8 divided by 8 is 1. And then 5 and 15. How many times does 5 go into 15? 3 times. Goes into itself once, goes in there 3 times. So now I can multiply straight across. So 1 times anything is itself. X to the 4th times y to the 5th. Okay, and this would be, so x squared, I try to line these up so they're right underneath each other. Y squared, and then if it's a number, that's going to go in the front. And that'll simplify my numbers. So x to the 4th over x squared is x squared. Y to the 5th, 5 minus 2 is going to be 3, so that would be y cubed. And then I still have my 3 in the denominator. So this would be your final answer. Alright, you try this division. X squared over 4 divided by x to the 4th y over 12y squared. All right, how do we think we did with part D? Think you got that one? Okay, so you're going to multiply by the reciprocal, so x squared over 4 times 12y squared over x to the 4th y. Did you guys cancel out the numbers here? Did you wait? Cancel them out here? Because 4 goes into 12 how many times? 3 goes into itself once. Okay, and then, so 3 is the number, I'll put that in front, and then I have x squared, y squared, and then I have x to the 4th y. And then once you get here, you can do your subtraction. Okay, so 3 has to stay on the top. 4 minus 2 is 2, so goes where the larger number is on the bottom. Y squared minus y is just y. So this should be your final answer. Okay, how do we do? Got everything in the right spot? All right, how are we feeling about part E? Looks like a lot, doesn't it? Let's just do one part at a time. Okay, so the first part, x to the 4th minus 9x squared. I'm just going to take out the GCF, okay? What's the GCF there? X to the 4th minus 9x squared. What can I take out of both? X squared. So if I factor out x squared, right, when you divide, you subtract. So 4 minus 2 is 2. So this is just x squared minus 9. And we'll FOIL that again in a second. Or we'll factor that again in a second. Okay, and then on the bottom here, I have a trinomial. Well, this trinomial isn't so bad because look, it's x squared. So you know you start with x and x, right? And then it has to multiply to 3, add to negative 4. Only things that multiply to 3 are what? Yeah, so we know this is negative 1, negative 3. And the order you put those in doesn't matter. Now, sometimes what I do is I'll factor it here. So x squared minus 16 is x plus 4, x minus 4. So then when I write it here, I already know what it's going to be because you're multiplying by the reciprocal, right? So whatever's in the denominator now moves to the numerator. And then I'll do the same thing with this. Now x to the 4th, right? This one has x cubed, this one has x squared. So I can take x squared out of all of those. And what would I be left with? X squared plus 2x minus 8. So x squared plus 2x minus 8.
For that one, why don't we put like in 2 sets?
We are.
Oh.
So I'm just doing it one part at a time.
All right.
So yeah, so this one you can factor down more. So we are going to do that. So I'm going to put the x squared there. And then yeah, we are going to factor it more. So if you have x squared, you have x and x. We need two numbers that multiply to negative 8 but add to 2. Do you know what they are? Yeah, so plus 4 minus 2. There's another one we can factor again, remember? What's this guy? Yep, so x plus 3, x minus 3. And I write the whole thing again just so now I'm like, okay, I know it's the green here. And now when you cancel, because there's a lot going on with this one, right? So now when I cancel, I need to be pretty methodical in the way I'm going about this. So I'll start with the top and I'll go one by one. So x squared, is that going to cancel out with another x squared in the denominator? Yes, so there and there. X plus 3, is there another x plus 3 in the denominator? Okay, so not an x plus 3, so that has to go in my final answer, so I'm going to write it down. So nothing canceled out with x plus 3, but you guys said x minus 3 does cancel, so yep. What about x plus 4? Does it cancel with anything?
Yeah.
Okay, so then we'll slash it. x minus 4, does that cancel with anything? Nope, so then we gotta write it here. And once you've done that, now you can just go back through the denominator and put what's left. So there's an x minus 1 left, and there's an x minus 2 left. And remember, you're keeping this in factored form, so you don't have to FOIL this. Okay, you can just leave it just like that. Okay, you guys got it? Alright, then let's try this one. We have 2x squared minus 7x minus 4 over x squared minus 9 divided by 4x squared minus 1 over 8x squared minus 28x, plus 12. We got some work to do with that one, huh? Okay, now the first one stays the same, so I can go ahead and factor the top, 2x and x. Has to multiply to negative 4, and then remember, we're going to be multiplying to get to negative 7. So the factors of 4 are 2 and 2, 4 and 4. See how 7 is really close to 8? So I know if I put a minus 4 here, 2 times negative 4 is, negative 8, so then this is just going to be a plus 1. So again, you're just guessing and checking with FOIL. X squared minus 9, that's your special pattern, and you had one just like it. And then times, so then these I'm gonna factor, and then I'll put them down there. This is, look, this is the difference of perfect squares, 4 and 1. So this is just 2x plus 1, 2x minus 1. 2x times 2x is 4x squared. This would be plus 2x minus 2x, 1 times negative 1. So that's a special pattern. So remember, that goes in the denominator because you're multiplying by the reciprocal. Now the bottom one looks kind of scary, but remember, the first thing you do is take out what they have in common. So what could you take out?
4.
Take out a 4. You can't take out an 8 because 8 doesn't go into 12. So if you take out the 4, right, divide by 4, you'll get 2x squared minus 7x plus 3. So then let's factor that down. 2x and x. I'm going to keep the 4 out here. This is another one where you have a prime number. So if it multiplies to 3, it's either 1 and 3 or 3 and 1. This is negative, so they're both minus. If I put the 3 here, I'll get negative 6 minus 1. And once you've done that, it's time to slash them out. So again, I recommend starting here and then just checking every single one. So 2x plus 1, yep, that has a match in the denominator. X minus 4, no match. And then if there's no match, we're going to keep it on top. 4, nope, so we're going to keep that on top. It should go on the front. 2x minus 1, yep, that cancels. X minus 3, that cancels. And then you have x plus 3 on the bottom. And then you can put this in parentheses or not here at the bottom. It doesn't matter because that's the only thing you have left. Alright, and then the last thing we're going to do today, we're going to use that same strategy to solve. And then you do have to check your solution, and that's because you have to make sure that you pay attention to the domain restrictions. So now that we're solving, you're going to have an equation. So your equation is x squared minus 25 over x minus 5 equals 14. And like I said, this is the same strategies that we've been doing. So we're going to factor the top. What do you guys notice about the top? Yeah, difference of 2 squares. So I have x plus 5 over x minus 5 on the bottom. So look how nice this is. These are going to cancel, and then you have a one-step algebra equation here, right? Minus 5 from both sides. X is going to equal what? 9. So all you have to do to check is look at your domain restrictions, okay? What can't the denominator be for this one? If you have x minus 5, what can't the denominator be? Okay, so x can't be 5. Is this 5? Nope, it's 9. Okay, so then this is going to be your solution. Okay, so if it's x can't be 5 and it's x equals 9, that's fine. Okay? Alright, I'm going to have you start part B. So you have x squared plus 3x minus 10 on top, x minus 2 on the bottom, equals 7. So this one's pretty nice to factor, right? It's x squared, so you start with x and x. What multiplies to 10 but adds to 3? Minus 2 plus 5. See how that's kind of a hint that you could try the x minus 2 to get them to cancel? And then all you have to do is solve for x. Now, again, we're going to check it. So when you check, all you have to do is figure out what the denominator can't be. So if you have x minus 2 equals 0, what can x be? Uh-oh, what's the problem? Oh no. So what will our solution be? We'll say no solution. So if x can't be 2 and you got x equals 2, there's no solution. Okay, this is called an extraneous solution. Okay, because if you were to plug in 2, 2 minus 2 would be 0. Can you have the denominator equal 0? Nope. Okay, so cross that off. X can't be 2. Okay? All right. Good job today. This is your 5-2 homework. If you can't complete all of it, make sure you practice some from each section. This is the part that's usually the hardest for people in Chapter 5 because it has all the factoring. So you really need to make sure that you do some of that practice.